podcast by Centroid. My name is Ajay Arora. I'm one of the managing partners and chief technology officer for Centroid. And with me today is one of my team members, Jacob Beasley, who heads the application deployment in the cloud infrastructure. So Jacob, why don't you tell us about yourself?
Yeah, thanks, AJ. So my name is Jacob Beasley. I'm one of the Centroid team members that runs a team of DevOps engineers who are really good at deploying software, running in the cloud or on-premise. We have a really deep background in Kubernetes as well, so we're kind of on the bleeding edge there. And excited to be here today.
Awesome. So you brought the word Kubernetes, so let's dive into it right away.
Mm-hmm.
Tell us about what's the difference between Kubernetes and like a local VMware deployment, and why Kubernetes is more important.
So a lot of us have deployed software on virtual machines. And with a virtual machine, you're standing up a new machine. You have to configure a lot of things to make that machine work correctly. Google was faced with this problem, and they said, we want to make a standard way to deploy everything. We want to be able to describe things in a consistent way. They called that first project the Borg project, named after Star Trek and the Borg who wanted to assimilate everything and make it the same. Yeah. So that's how Kubernetes was born. And so Kubernetes gives you a standard way to describe a deployment. So how big is it? How many of them do you need? Does it need shared storage, like NFS storage or other kinds of storage? Does it need configuration variables? Does it need to load secrets from somewhere? Does it need to ingress traffic? You can take all of these things, package them up in a consistent way, and tell Kubernetes to make it so, and then it makes it so.
But doesn't it sounds more like a VM also, where I can take a VM template and tell the template to actually create more VMs for it?
Absolutely. It's very similar, but it boots up faster than a VM.
Okay.
So it uses this technology called containers, which trick an operating system or an application into thinking it's in a VM. So what a container does is it uses a bunch of features of the Linux kernel to trick an application into thinking it's a VM. So it isolates CPU, memory, storage, and it also can run as a different user account using different features like namespacing in the Linux VM. So it's pretty cool. And so a VM image might take, what would you say, a couple minutes to boot up?
Yep.
Right? Whereas a container can download and run in a matter of seconds, especially a well-optimized container might only be 20, 30, 40 megabytes and could even be cached locally and passed over the network with compression. It could be very fast. You could have containers that boot up in maybe 5 to 10 seconds, maybe up to 30 seconds, whereas a VM might take many minutes.
Yep. And
the overhead of a VM, you always have a whole operating system kernel. Whereas for a container, you're actually running inside you're sharing an operating system with other containers. So that overhead per container might only be a megabyte or something, or even less. It could be, we're talking kilobytes, the overhead of a process on Linux. So very small.
So basically it standardizes the operating system underneath it and shares it as a single foundation.
Yes. And you package up your applications like a VM image. We call them container images, but they boot up faster. They pull in the operating system dependencies and any application code or dependencies you have. And then you also can scan that. So it's very secure and it boots up really fast. So
if it boots up that fast and can use and standardize it, that means I can scale it very quickly as well for customers.
That's what's really attractive. And you can a lot of applications, especially in this whole microservices movement, you have these microservices that sitting still might only use, say, 0.1 CPUs or less, and maybe 100 megas of RAM. There is no VM you can get that's that tiny.
Absolutely.
So now you can spin up a VM and run 100 applications on that VM, or however many you need. And so you get really, really good resource utilization, and you can dynamically scale as well. So it works really well, especially for microservices, but also really well for even lower environments where you have monolithic apps, but in your dev environments, your test environments, you're sitting still using nothing, right?
Okay.
But then occasionally you scale up for a load test. Kubernetes does that really well. So huge cost savings we're seeing. Yep. And Oracle has a pretty good Kubernetes engine that, every cloud vendor now has a Kubernetes engine. We've used, at Centroid, a lot of different ones. We like Oracle's because they take vanilla Kubernetes and package it up, where some of the competitors, it's harder, right? They add a lot of magic to it, which is tough.
So you're talking about basically OKE, the Oracle's Kubernetes engine. So tell us, what's your experience has been with the OKE so far?
It's been good. So at the end of the day, they're using, for the most part, vanilla Kubernetes.
Okay.
And they'll spin up a control plane for you. It has integration with Oracle's ID service. So you can actually say these groups of users have access to these roles in Kubernetes.
Sure.
So it's using Kubernetes native concepts, whereas some of the competitors don't do that. Also, we like that they don't like rip out and create their own policy engine.
Okay.
They use the native policy engine that Kubernetes has built in, but it does integrate with Oracle's stuff really well. So it's good. And by default, it seems to run a bit more securely than some of the competitors. Specifically, Amazon tends to run things as privileged by default, which is kind of a big no-no in Kubernetes security. It's like running everything as root, whereas Oracle tends to do a much better job. Their defaults are more the Kubernetes defaults, which has a lower learning curve then and makes it very flexible.
Okay. So if I am a brand new customer coming in, I want to deploy on Kubernetes because that's what I've heard, that it's optimizes, or they're listening to this podcast also. Okay. How can I get started, number one? And number two, what are kind of workloads are qualified to go into Kubernetes in containers?
Yeah, good question. So the first question is, how do I get started? So Oracle has a learning pathway that's available free to all of its customers that walks you through the basics. There are some prerequisite knowledge that you'll need to get. So one of them is you should probably do a little tutorial on Docker and containers and know how to build a Docker image. It's not hard. If you've ever done any shell scripting, at the end of the day, it's just a list of tasks. Copy in these files, run these commands, not complicated. Then after you've done that, you're going to have to deploy an application to Kubernetes, and you create what's called a manifest, which is just a config file, right? And then you tell it to make it so. Now, we usually don't use manifest directly, though. We use this tool called Helm to deploy your code. And Helm, you think Kubernetes likes to use all these nautical things. Their logo is like a wheel, like driving. And Helm, of course, is the helm of a ship, right? So with Helm, you can template out your configuration. I know one thing we've done is we actually have some open source projects people can reach out and ask. We have some pre-made Helm charts that people can use where they can just configure a single config file and deploy an entire application, which could even have multiple containers, multiple applications, health checks, everything. And it's already templated out. You just fill in a few parameters, hit go, and it boots up. So it's really nice. And what was the second question again?
So so Kubernetes side, how do I qualify? Which workloads do qualify for Kubernetes? Because not everything can be put in Kubernetes, or is it, or can
almost anything can be, but there is a few qualifications. So there is such a thing as a Windows Kubernetes container. But most people don't use it. We usually recommend, if you're using Windows, maybe look at something that's not Kubernetes. You can do it, but Windows doesn't play as nicely with Kubernetes. Even the smallest container for Windows is quite large, like hundreds of megabytes, which means some of the benefits that we talked about that Kubernetes has, if the overhead of a Windows container is as big as a VM, why? Why
do it? Okay.
But so usually I look for Linux workloads for Kubernetes more than Windows. The second thing is if you have an application that can't be set up in an automated fashion, so think like certain kinds of legacy vendor applications, maybe you want to look at just a traditional VM. So something where you some kind of application that you have to click through to set up. Really, you want things that you can set up programmatically, which for most modern applications isn't a problem. So if you're using Java, .NET, Python, PHP, whatever, these are great candidates for running in a container. And if you're using any modern frameworks, they oftentimes have example Docker files and Helm charts that you can use. You can start with that. You don't have to start from scratch. So I will also say too that if your apps are really, really big, the advantage of Kubernetes isn't, so if it needs 32 CPUs to operate, the advantage of Kubernetes over a VM gets smaller, but that doesn't mean you can't use it. Some people will use it. Or if the app needs elevated privileges, again, the advantage of Kubernetes is smaller, but you can use it. You kind of have to decide, do I want to use Kubernetes instead of Ansible for this gigantic VM app? So where I see it the most common is when you have horizontally scalable applications. Right? Where you want to run a lot of them on a shared VM. Doesn't have to be that way. I'm even seeing people begin to use Kubernetes for big VM apps because they like to use tooling and things that gives you, Kubernetes allows you to do tooling and policy management, which you can do for VMs, but Kubernetes by default has more of that baked in. So you do see people even using it for things that aren't great candidates,
Sure.
simply because the security team can apply a lot of policies to it.
Okay.
Yeah.
Absolutely. So we talked about how we get started, what workloads qualify for it. So what I've been doing in Centroid as part of our team is, tell us more about some of the projects you're doing for Kubernetes, and if customers want to start with that, how can they approach us and things like that?
Yeah. So if you go and you talk to people about starting up a Kubernetes cluster, one thing you will learn very quickly is usually people don't just run Kubernetes.
Okay.
Right. Just like if we're running VM workloads, we're running CrowdStrike, and we're running all these other, monitoring suites, New Relic, whatever, right? SolarWinds. Same thing with Kubernetes, but the ecosystem's different.
Okay.
So think in VM land, you'll use CrowdStrike, right?
Yes.
You might still use CrowdStrike on a Kubernetes node, maybe, right? But there are different tools for monitoring and policies.
Okay.
So what we've done is we've rolled up a kind of a standard set of tools that we put on every cluster by default.
Okay.
And then we tune it to a customer's needs. So we tend to put in things like some kind of traffic ingressing, some kind of load balancer. So either Nginx or Istio load balancing. We tend to install a tool called Cert Manager, which will automatically sign SSL certs for you.
Okay.
So you can just say, I need to take in traffic on this host name, and it will automatically go out and get a cert doing a DNS or an HTTP challenge.
Okay.
Similar to what people would do manually to verify identity, but it's all automatic. So it's kind of magic. You just say, my app needs to go here, and if the DNS entry exists, you get a cert.
Okay.
It's cool. We install another tool called Prometheus Stack, and that gives you Prometheus database for metrics, automatic scraping of all your apps, as well as the ability to plug in other scrapers for things like Cassandra or MongoDB. You get those metrics, right?
Okay.
And then it also gives you a website called Grafana. It's a tool that gives you a user interface for viewing graphs and dashboards and building custom dashboards. And it comes baked with dashboards for resource utilization and things. So you can start doing tuning. It also comes baked with another tool called Alert Manager. And what Alert Manager does is it has about 150 monitoring queries already built in to say your app's crashing or there's issues. And then finally, we have a tool called Minesweeper, which does security and policy management. So it's like you get this entire production-ready cluster, and we can set it up for people probably faster than anybody we've seen. Right, we're very quick. We've had a lot of fun migrating people and getting them in, and really, it's about getting people migrated quickly so they can focus on building products. We find most of our customers, really, their dev teams, they're primarily focused on feature function.
Okay.
They want compliance, they want policy management, they want security, they want monitoring, but they want that quickly so people can go build code that does real things. Right?
Absolutely.
Yeah.
So what are we doing at Cloud World from Centroid perspective to cover some of the topics of Kubernetes if somebody wants to learn it or talk to you guys about?
Yeah, so we're doing some roundtables with executives from different companies where we talk about real use cases, real business cases they're having, and we compare the options and talk through the details of how they can actually, how they would solve that problem, right? So things like, how do I run on-premise and in the cloud and cost optimize, right? What are my options?
Okay.
How do I secure things? How do I do encryption, between the two, on-premise and cloud, right? All these kinds of fun things.
Sure. No, absolutely.
Yeah.
So anything you would like to add about, from the Cloud World, anything, or what are you looking forward to learning from Cloud World also?
Yeah, looking forward to seeing where Oracle Kubernetes Engine is going. Looking forward to seeing some of the tools Oracle's baking in. Every cloud provider puts in a little bit of secret sauce.
Sure.
And I want to see that secret sauce if we can, which is good. And it's going to be exciting, going to be good. And, looking forward to the coming couple of years to see where they take it.
Absolutely. So guys, that's all from our side. Wrapping up the podcast on Kubernetes from Centroid. Thank you.
Thanks.